In this video, we're going to explore the concept of forcing, only this time in its application to input bits rather than output bits. Right now I have a very simple program running in my MicroLogix 1000 PLC, a single examinative closed or normally open contact running over to a single output enabled instruction. And so if I energize the input, this imaginary contact closes, sending imaginary power to the imaginary coil, and then activates that output channel. What I want to show you is how I can force input bits as well as output bits. And so to do this, I'm going to go over here. I can go down to my force right here and enter a 1 for a force. I also want to show you can simply right click on the contact. Down here it says force on. I'm going to force it on. As we see, the word on pops up in red. I'm passing imaginary power onto my imaginary coil, and I'm energizing my output. If I turn my input switch on and off, we see absolutely nothing happens here. In fact, if we go over to the PLC itself, we notice nothing happening here either. Flipping the bit on and off, you can see the input bit is turning on and off right there. The output bit, however, remains on because of the force we have placed on the input. The force light, of course, also comes on, showing us that we have a force condition in effect. We can examine this in the data file table. I can bring up the input data file view right here, and we see that indeed bit 1 is showing up in red, showing we have a force condition in effect on that bit. I can turn that switch on and off, but I'm seeing no effect on the input word because that has been forced, overwritten. If I go to the output reference, take a look at my output file, there's my corresponding output bit for element 0, bit 0. It's in a 1 condition because the program is telling it to be a 1. Notice this does not show up in red. The input does, the output doesn't, because the force we have placed on the bit is on the input bit, not on the output. This output bit is a 1 because the program is telling it to be a 1. The input bit is a 1 because we have forced it, not because it's being told to by the actual electrical status of that input. So we see the input showing up as a 1, and the output is a 1, but it's not being forced as it is here. This is red, this is the normal blue color. If I turn my input switch on and off, again we see no change anywhere because this bit is being forced on. I can go down to my force files view down there to inputs, double click this, bring it over, and I see where, as all the other bits here show up as dots, I have a 1 right there for that bit, showing me that I actually do have a force that's in effect. I'm going to close these windows, just go back to my ladder display, and show you how to manage these forces here just from the ladder logic editor. So you can see right now I have a force condition in effect as illustrated by that red on. If I right click on the contact and come down here, I can do a couple things with this. I can either remove the force or I can force it to the off condition. If I force it to the off condition, what we see is the red word off show up just below the contact, and no matter what I do now with my input switch, that imaginary contact neither opens nor closes. My output always remains off. So panning back to the PLC, I see my input switch turning on and off, and that is energizing and de-energizing the input, the electrical input of the PLC. My output bit, however, does absolutely nothing. Its hands are pretty much tied, so to speak, because of how I forced the input bit in the program. And once again, we see the force light come on, telling us that the force is in effect. So the program has been rendered inoperational due to the fact that I have forced that 1 bit. I shouldn't say the program's inoperational. The program's still scanning and still executing, but it's really not responding to the input because I've overridden the input. Now again, right click there, and I can also remove the force. So I can remove the force. Now it goes back to normal, and if I turn the switch on and off, we see the program operating as it normally would. Something else I can show you. We can force the output this time just for fun. I can force that on. There we go. And now, whether or not I turn my input on and off, my output always remains on because it is now forced. And going down to the output file, data file view, I can show you that right here. It shows up as a 1, then a 0, then a 1, then a 0, but it's in red, telling me that actually I'm forced all the time. If I go to my force view, I can see that right here, that first bit is always in a 1 status because it's forced. Another way to view manage the forces is to look up here in this corner of the screen. It says right here, forces are installed. And up here I can remove all the forces if I wish. And so that's another way I can remove forces from the program if I'm done with whatever diagnostic test I'm doing that require the forces. I can show you that right here. Click on that. I remove all the forces in the processor, yes. And then if this bit or any other bits were forced to a certain condition, those forces will be removed now and the program's back in its normal operation. So, another view of how to force bits in an Allen Bradley PLC.